oral tip, and that's the direction that they're swimming in. And they begin to press it very tightly to the substratum, and so that the end is spread out into a disc-like adhesive area. And so what it begins to do is the larva begins to contract. It goes from this elongate body to a more barrel shape, spherical shape, to finally flattening out into a disc. And in less than 10 hours or so, metamorphosis is complete. And you see the internal organization of the polyp if you look at it under a dissecting microscope. And they begin secreting their basal calcareous plates. So how do we measure flow and attachment strengths? We use something called the flow cell here. And this is the device shown. It stretches 1 meter in length. And the test chamber here is 10 centimeters wide and 7 millimeters high. And you have this reservoir in which we fill with seawater that gets pumped through here, causing a unidirectional flow past the test chamber where the larvae are held and through a series of colonnators. And then this is hooked up to a machine in which we can turn up the dial to increase flow speed. And this is usually hooked up to a video camera and a monitor to record the process. And to take a closer look at this, the video camera is attached to a microscope tube that's mounted onto a dissecting microscope that's pulled over the working chamber. And to show you a closer picture of the working chamber, this is a chamber with defined wall shear stresses. So it's already been measured out by its designer. And these slides here are where the larvae are. So basically we've settled the larvae on a slide, and they get held in this test chamber via vacuum suction. So the general methods that we go through is we take 3-day-old planulae and expose them to a biofilm slide in a petri dish, either for 30 seconds just for them to loosely attach, or for 10 hours to have them complete metamorphosis. And then the slides are lifted and transferred over to the chamber of the flow cell and held in place by suction, and the clear lid on top gets replaced. And finally, the microscope gets pulled into place to record the whole process. So here, what I'm going to show next is a clip of planulae that have been tested within 30 minutes of attachment. So here, flow is going from right to left. And you start to see the larvae getting blown off. The slip of paper we'd insert in between indicates to us that we have this increase in flow rate from 1 to 2.1 pascals. And this one is just desperately secreting this mucus strand that actually helps it hang on while exhibiting that sort of somersault process in which it's kind of flipping around on both ends to still desperately attach to the biofilm. And next we're going to take a look at the juveniles that had been exposed to the biofilm for 10.5 hours. And so they've already undergone settlement and metamorphosis. And so here's the clip for that. And basically this is the juvenile that has already been blown by the water flow and kind of flipped backwards. And here's the basal disc that's still attached to the slide. And it's just, the poor thing's just being torn off there. And so as you can see, it takes a greater amount of force to actually blow off that juvenile. So when you graph the data, we have the mean removal velocity here in centimeters per second, and the two settling stages that we have, those that are exposed to the biofilm for 30 minutes and for 10 hours. And what you see here is there are two different color morphs of Poslepora that we have here in Hawaii that releases planulae during different phases of the moon. However, they don't seem to show any difference in their attachment strengths if you compare here yellow and brown here. But of course, the juveniles, it definitely takes them a greater force to be removed. Now, in measuring flow in centimeters per second, basically what you're looking at there is an average flow rate that goes through the entire flow cell. And so with the larvae that is attached to the biofilm there, basically they're at that boundary layer. They're within that boundary layer. And measuring flow rate, getting an average flow rate in centimeters per second doesn't characterize that boundary layer that well. And so, so calculating the shear force in pascals would give you a better idea in terms of numbers of what's going on in that boundary layer. And so that's what you have here when those numbers are converted.